Welcome back, math friends. This is AP Calculus, section 3.6, day 2 notes. Yesterday in 3.6, day 1, we learned what implicit differentiation is and how it's a tool that we can use to differentiate functions where we can't necessarily solve for y or isolate y on one side of an equal sign. So in example 1, they are asking us to use implicit differentiation to find an equation for the tangent line to the curve at the given point. Notice that our equation, sine of x plus y, is equal to 2x minus 2y. We are not able to solve that equation for y. So this is a situation where implicit differentiation is a requirement. We can't do it without. And the point of tangency where we want this tangent line is the point pi pi. So our first job, obviously, if we want to write an equation of a tangent line, is we need a slope. And the way that we get our slope is by finding the derivative of our function at the x value where we want the tangent line to be at the point pi pi, so the x value would be pi. So our first step here is going to be find our derivative, or in this case, find dy dx. So step 1 here, I am going to find dy dx, which means that I am going to take the derivative of y with respect to x of the left side and the derivative of y with respect to x of the right side. And on the left-hand side, when I do the derivative of sine of something, this is going to be chain rule, right? Because I have a function inside of, actually I have two functions inside of my sine function. So this is going to be chain rule. I'm going to start on the outside and work my way in. The derivative of sine is cosine. So I am going to have cosine of what's inside. But now I have to multiply by the derivative of x plus y. The derivative of x is 1. The derivative of y is going to be dy dx, because remember, y is a function of x. So it would be 1 times dy dx. On the other side of the equal sign, the derivative of 2x is 2. And the derivative of negative 2y is going to be negative 2 times dy dx. Again, every time I have a term with y, I have to think chain rule. Y is a function of x, so I have to always multiply by the derivative of y, which is dy dx. All right, my next step, obviously on the left-hand side, would be to distribute the cosine x plus y to the 1 and to the dy dx. So I get cosine x plus y plus cosine x plus y times dy dx. And over here, I still have 2 minus 2 times dy dx. And just like always, I would like to solve for dy dx. So I'm going to move the negative 2 dy dx from the right side to the left side. So that's going to become positive 2 dy dx plus the cosine of x plus y dy dx. And then on the other side, I still have the 2, and then I'm going to move the cosine x plus y from the left to the right, so I'm going to subtract cosine x plus y. And then I factor out my dy dx. So I'm left with 2 plus cosine x plus y is equal to 2 minus cosine x plus y. And then, of course, my last step is going to be to divide both sides by the 2 plus cos x plus y. So my numerator will be 2 minus cosine x plus y divided by, and my denominator will be 2 plus cosine x plus y. So here is an expression for my first derivative, or dy dx. So now my second step is going to be to find the slope. And I'm going to find the slope using the fact that the point at which I want the slope is the point pi pi. So I'm going to plug pi pi in for x and y into my derivative equation, and that will give me my slope. So my step 2 is going to be to find m using the point pi pi. So I know my slope is going to be equal to, and again, I'm just plugging pi in for x and y in my dy dx equation. So slope is going to be equal to 2 minus cosine of pi plus pi divided by cosine of pi plus pi plus 2. Well, pi plus pi is 2 pi. So I have 2 minus cosine of 2 pi over, and again, pi plus pi is 2 pi. Cosine of 2 pi plus 2. Well, the cosine of 2 pi is 1, right? Ordered circle, 2 pi is at 0 and at 2 pi, it's the start of the unit circle. The ordered pair there is 1, 0. Cosine is the x value, or 1. So in my numerator, I have 2 minus 1, and in my denominator, I have 1 plus 2. 2 minus 1 is 1, 1 plus 2 is 3. So the slope of my tangent line is 1 over 3. And then finally, the last step in my problem is going to be to write the equation of my tangent line. And I know that my slope is 1/3, and I know that my point is pi pi. So y minus pi is going to be equal to 1/3 times x minus pi. I distribute, and I get 1/3 x minus pi over 3. But then when I add the pi from the other side and I combine like terms, I get y equals 1/3 x, negative pi over 3 plus pi is like 3 pi over 3, so this gives me 2 pi over 3 for my y-intercept. So here's the equation of my tangent line to the curve at the point pi pi. Example 2 wants us to find y prime prime by implicit differentiation. So not just the first derivative, but the second derivative. But obviously, if we can find a first derivative by implicit differentiation, we can also find a second derivative. Now, we're going to make this problem a little bit more fun and a little bit more challenging. And we are going to write our answer in terms of only y. Which means we will have to do some substitutions to make this happen. So when we're done, our y prime prime should only have y in it. Okay, it shouldn't have x in it, and it shouldn't have y prime in it. It should only have y in it when we're done. I'm going to begin example 2 the same way I begin every other example. I'm going to show that I'm doing implicit differentiation on the left side and on the right side of the equal sign. So dy dx of 9x squared plus y squared equals dy dx of 9. And then when I take the derivative of the first term, the derivative of 9x squared is going to be 18x. And the derivative of y squared, bring down the 2, is going to be 2y, but this is chain rule, remember, so multiply by the derivative of y, which is y prime. I'm going to use y prime instead of dy dx, just because the instructions for the problem told us to find y prime prime. So that's the notation I'm going to use. And then on the right side of the equal sign, the derivative of 9, constant term, is going to be 0. So now I would like to solve for y prime. So I'm going to subtract the 18x over to the other side. And then I'm going to divide both sides by 2y. So I get y prime is equal to negative 18 divided by 2 is negative 9x over y. So there is an expression for my first derivative, y prime. I may need that at some point later in the problem. But again, my goal here is y prime prime. So now I need to take the derivative of y prime. The notation, the implicit notation, or the implicit differentiation notation for the second derivative is d squared y dx squared of y prime is equal to d squared y dx squared of negative 9x over y. Well, the derivative with respect to y of y prime is going to be y prime prime. And then on the other side, I have a quotient. So I'm going to need to do quotient rule, which we know is low d high minus high d low, y prime is the derivative of y, all over low squared. Okay, so I can do a little bit of simplifying here. I get y prime prime is equal to negative 9y minus a negative will become plus 9xy prime, and this is divided by y squared. Okay, so the first thing I noticed, remember, I want my answer to be in terms of only y. Right now I have a y prime in my answer, so I am going to right now do a substitution. Right here I am going to put what y prime is equal to in for y prime, which will then give me all x's and y's, and we'll see where we're at from there. So when I do that substitution, I get y prime prime is equal to, my first term was negative 9y plus 9x times negative 9x over y. That was my y prime. And this is divided by y squared. Okay, so now I am going to simplify this a bit here. I am going to divide my first term by y squared, and I'm going to divide my second term by y squared. This is all just algebra, my friends. So we have y prime prime is equal to negative 9y over y squared is going to simplify to negative 9 over y. And then my second term, 9x times negative 9x is going to be negative 81x squared. And then dividing by y and dividing by y squared is going to make this term in the denominator y cubed. Now, wouldn't it be nice if I had a common denominator here? So if I multiply my first denominator by y squared, I have to multiply my numerator by y squared. So then I would have y prime prime is equal to negative 9y squared over y cubed minus 81x squared over y cubed. And I'm getting close to something good here. My original equation for this problem, I'm going to write it down up here, was 9x squared plus y squared equals 9. So what if I were to factor out a negative 9 from both terms? Then I would have y prime prime is equal to negative 9, and then I would have y squared plus 9x squared, and then these are both divided by y cubed. Well, look at my original problem. My original problem was that 9x squared plus y squared was equal to 9. So what if I just substitute a 9 in there? That takes care of the problem where I have an x that I don't want. So my y prime prime is going to be negative 9 times y squared plus 9x squared is 9 over y cubed. So I get a final answer of negative 81 over y cubed. So I have officially written my second derivative in terms of only y. And that required some implicit differentiation and several fancy substitutions using some algebra along the way.